Hello, my name is Ishan Raza and my student ID is 77376728. Today I am excited to present my project IoT Anomaly Detection System using machine learning. This project is part of MSc Information Technology degree at Leeds Beckett University. Over the next few minutes I will guide you through the development of the system from the initial concept to the final outcomes. In the introduction, the IoT anomaly detection system is designed to identify and classify cybersecurity threats within IoT and IIoT networks using machine learning. It utilizes the edge IIoT datasets which includes data from the various IoT devices and categorize 14 distinct attack types into the 5 primary threats. After processing an exploratory data system analysis, several supervised machine learning models, including AdaBoost, SVM, and CN trees, were trained for the accurate threat detections. The system performance was evaluated using classification report and confusion matrices, demonstrating its effectiveness in identifying cyber anomalies. The project provides a robust platform for developing advanced intrusion detection system that's called IDS in IoT networks and IoT environments. So the aim of the project is this aim is to enhance security in IoT networks, designing and constructing a dependable system for detecting and controlling hazards associated with IoT setting is the main focus of the research. Objectives of the project: to eliminate the shortcomings of current security measures. This investigation will seek out the present issues and gaps in the cutting edge IoT security. Testing and comparison with real world IoT and a basic data set like KDD CUP99 is necessary for the evaluating machine learning algorithms. Neural networks, decision trees, support vector machines, and Gaussian naive are all good options. Literature review on IoT and IIoT security highlights the growing vulnerability of connected devices to cyber attacks due to the widespread adoption and limited built-in security features. Traditional intrusion detection systems, that's IDS, are often inadequate for these dynamic environments, prompting the need of the advanced solutions. A recent study emphasizes the effectiveness of machine learning in anomaly detection, particularly in identifying complex attacks pattern in real time. The Edge IIoT sets dataset is recognized as a comprehensive resource incorporating in various layers of IoT architecture and offering realistic scenarios for training and evaluating IDS models. The project builds on these findings, aiming to enhance detection accuracy and providing actionable insights for the securing IIoT ecosystems. So next we will discuss about methodologies of project. So first methodology is data collection. The project utilized the Edge IIoT set datasets which contain comprehensive data from the various IoT and IIoT devices across multiple layers of network architectures. This dataset includes both normal and anomalous data and 14 distinct attack types categorized into 5 primary threat groups. The second one is data processing. The collected data was pre-processed to ensure its quality and suitability for machine learning models. This involves handling missing values and removing duplicates, normalization feature values, and encoding categories variables. The data was then split into training and testing sets to validate model performance. The third one is data visualizations. Exploratory data analysis was conducted to understand the relationship between the different features and the target variables. Visualization techniques such as correction matrices, heat maps, and distribution plots were used to identify patterns and potential anomalies in the dataset. The fourth one is model training. Various machine learning models include AdaBoost, gradient boostings, decision trees, logistic regressions, SVM, and passive aggressive classifiers. These models were trained on the pre-processed data. These models were chosen for their proven effectiveness in the classification tasks. Model evaluation: the trained model were evaluated using classification report and then confusion matrix to assess their accuracy, precision, recall, and F1 scores. This helped in identifying which model performed best in detecting and classifying cyber threats. Model comparison the performance of all the models were compared to determine the most effective approach, and the comparison focused on the metrics like accuracy, computational efficiency, robustness to overfitting, guiding to the selection of the optimal model for IoT anomaly detections. So first of all, I upload the data in my Google Drive, and then I import it here. Then I import some libraries such as NumPy, Pandas, MATLAB, Seaborn, sklearn, etc. So after that, I use the command read, and all the data from the previous pre-processed data is here. I have modified some columns that I need from all of the data set, and from those data set I have selected 10 of the rows. So here are the 10 rows. By using the data info, I can get all of the 10 rows, uh, data name, column names, and the data types. Next I will train the data. uh, Here is the train data distribution. So in this column we can get standard deviations, minimum and maximum values of the data. I will drop some of the columns which are irrelevant and useless for our data. So all of these columns I will drop here, and next I will check the selected columns which are empty. If they are empty, I will drop them as well, but here all of the columns are not null or empty. Now I check duplications. It was the duplications here, so I remove it. Now the data encoding. In data encoding, I check for non-numerical columns, and I do encoding by label encoding, where are 14 type of attacks encoding from, and I start encoding and it was from 0 to 14. Then I name those attacks with attack type, and in machine learning, attack type is also called Y, which is the predictions. In data splitting, I split the data into two parts, that is X and Y, train and tested data. So that in the data scaling process, it process that brings features in the set of similar range. Robustly used to scale the features of training and testing data. For the training, I use xtrain, and for testing, I use xtest. So now I will move back to the modules. So I will discuss all the results there. So after the implementation of the projects, let's have a look on all of the models and the results of the models which I have applied in this project. So the first of all is ADA boost classifier. The ADA boost classifier, if we look at these results, all the Excel precisions, recollections, and F1 scores are scoring 1.0 across all the measures, and no false positive or negative were found in these results. And an area over the curve which is also shown at 1.0, which and also it indicates 1.0. That means that the model is working perfectly. So the second one is classifier gradient boost. So the second is classifier gradient boost. The classifier gradient boost is mostly similar to the ADA boost because it has flawless precision and recall, and all F1 scores are similar to the ADA boost classifier, that is 1.0, and it also has not shown any false positive and false negatives, and this means that this model is also working perfectly. So the third one is decision tree classifier. The choice classifier performs well but not perfectly. It is just because if we have look at all of the results like precisions, accuracy, recalls, and F1 rating, all of the values are slightly different as compared to the first two models. So it here also found a lot of falses and negativities. So the final AUC value of indicates that the model distinguishes classes well but is less accurate than other boost and gradient boost classifiers. The fourth one is linear discriminant analysis. A high sensitive of 1.0 means the LDA model successfully recognizes all the positive cases. However, its precisions and accuracies are 0.88 and 0.888. The F1 score balance accuracy and the recall at 0.93, which is slightly different to the others. The confirmed matrix catches practically all genuine attacks but misclassifies many regular classes as attack with 425 false positive and a 6 false negatives. The AUC 0.6 indicates good but not great performance. This model is sensitive yet imprecise, making it suitable for situations where collecting every positive instance is crucial despite greater than every false positives. The fifth one is logistic regression. Logistic regression perform well with 0.895 accuracies and 0.997 sensitivities and 0.891 precisions. The F1 rating is 0.941, which suggesting strong accuracy and recall. The confirmed matrix shows 3922 incorrect positives and 92 fake negatives. So this model is strong and generalizable, making it suitable for numerous practical uses. So the sixth one is classifier passive aggressive. So if we have a look at all of these results like accuracy, sensitivities, precisions and F1 score, but we can see that confirmed matrix mix a lot of 4178 erroneous positives and 1085 false negatives, and we also can see that AUC 0.81 score suggests it is less successful than the other all models. The seventh and the last is linear SVC kernel SVM. So if we have a look at all of these results like accuracy, sensitivity, precisions and F1 score, we can see that the confirmed matrix has 4200 false alarms and 1115 fake negatives. This model can discriminate both positive and negative categories moderately according to its AUC score of 0.82. The model balances accuracy and recall but has a greater error than the decision trees or logic regressions. Here is a comparison of result of confirmed matrices and classification reports. So here we can also see that R curves of other boost classifier and the gradient boosting is so here we can also see the curves of the boost classifier and gradient boostings and the rest of all the other models and same confirmed matrices. So let's discuss which is the best model for this program. So other boost and gradient boost classifier scores ideal scoring, offer lifting, suggesting offer lifting, balance performing balance performance, make the decision tree encoder strong and trustfully. LDA is sensitive yet imprecise, useful for the application that need all logistic regressions. Logistic regression is balanced and robust, ideal for many practical applications. The passive aggression classification and SVC linear SVC kernel are less efficient but balance accuracy and recall. So each type has pros and cons, but therefore the decisions should rely on the application needs such as sensitivity, accuracy or mix of both. What is the conclusion of this project? All in all, the Edge IoT the Edge IIoT set project provide a good opportunity to progressive cybersecurity study and practice. A detailed structure of the given dataset and good performance of used machine learning models demonstrate the possibilities of further enhancement of threats identification and concentrations. Thank you for watching my presentation on IoT anomaly detection system using machine learning. I hope this video provide a clear understanding of the project, its purpose and the outcomes. I appreciate your time and look forward to any feedback or question you may have. Thank you again for your supporting through the project.